Hello all. In this session, we discuss hill climb algorithm in continuation to my last session. Let us solve a small problem called block world problem. Before this, let me reintroduce what is a hill climbing. Hill climbing algorithm is a popular local search algorithm that is analogous to a blindfold hill climber who tries to find the best path to reach from bottom of the hill to the top of the hill. So, by overcoming different problems like local maxima, flattened surfaces and ridge problems, how he reaches. The process he makes during the hill climbing, we mimic that in our problem solving, AA problem solving. So, there we calculated one heuristic function that decides us what is the next function, next state we have to consider to make a to reach our goal. Now, let us see one block world problem. Suppose one robo is placing these blocks. There are 3 blocks ABC. One robo arm is placing those 3 blocks into this order. This is the starting state of the problem and this is the goal state of the problem. Means my robo arm placed these 3 discs in this order that C should be placed on B and A is separate. So, to reach this goal state, how my robo program inside that robo, how it solves this problem. So, as usual, every problem we represented as a search algorithm, problem means where we search a path from goal state to the path from start state to the goal state, right. Let us see one problem, right. Suppose there is a blocks like this A, B, C, D, where this is a starting state of the problem, right, where blocks are arranged in this order. First block is B, on B, C is placed, D is placed on C, A is placed on B. This is a starting state of my problem. What is the goal state of my problem is these blocks should be arranged in this order A, B, C, D. Now, if I use a hill climbing algorithm, how I solve this problem? How my algorithm takes starts from this state and reaches to this state. So, for this what I do, first step in here we prepare one heuristic function that selects the best possible state from the given state. Right here I use one local heuristic. Local heuristic means +1 for each block that is resting on the thing that is supposed to be resting on. Suppose here this C is rest on the B, D rest on the C, A rest on the B. If something is rest on as it is supposed to be rest in the goal state. Suppose in goal state B is on top of A, but here B is starting of A, so I send -1. In goal state C is on top of B, that is why I send +1. In goal state D is on top of C, I send +1. And A is top, but A should be placed on bottom, so SN means if a block is exactly placed where it is supposed to be placed in the goal state, we assign +1. If it is not as in the goal state, we assign -1. In the goals also I send all are +1 because they are goal state, they follow the order. Now this is the start state, means start state is 2, is if you add all these numbers you get the 0, and goal state is 4, means my problem starts from 0 to 4. See now what are the first, this is the first I represented my problem using some constraints. That is why local search algorithms basically they are constraint satisfaction problem. I have given some constraints. Now this is starting state of my problem. Now my 0, I want to reach, what is my goal state? I want to reach 4. So if I say first I place A, so when I place A, Now first state, from this state I change it to the state. Suppose I placed A from top of the block to the on this one. Now as usual, now A is here. What is A? A is in goal, A is plus 1, and as usual it is minus 1, 1, 1, because if they are supposed to be exactly placed in the goal, what is my problem? See, totally if you combine 3 minus 1, I get 2. The next state, what is the possible? There are 3 possible states. This is the first state. From this state, my problem moved to the next state. Now I placed D. Now I can place D on top of A. When I place D on top of A, as per my constraint, A I have given as plus 1, but D as minus 1, because my problem says that D should be placed on C, but here I placed D on A, so I assigned minus 1. A is as usual, it is supposed to be there exactly as in goal state. Here B is not in C, but C is placed on B as in my goal state. Here I placed 1. So when you add all these things, 1 minus 1 0, minus 1 plus 1 0, 2 minus 2, totally you reached 0. This is one possible state from this state. Next, suppose I place D not on the top of D, if separately if I placed. So as in goal, bottom is A, but here it is D, so I assign minus 1. My heuristic function assigns minus 1 to the system. Now here it is A as usual, goal state also A is in the bottom 1, B minus 1, and C on top of B 1. Again here also you get 2 states. My estimation function gives 0 for 2 possible states. So this is nothing but here blindly I am trying all possible ways. Here 0 means I achieved a local maximus problem in hill climbing, where means from this state you get confusion which state I should go, direction of the solving problem. So here the problem is I reached 0 0 state, means I have not reached goal state, but my estimations are giving 0, means from this point I cannot reach my goal state. So here because problem is in my heuristic function, means how I calculated my estimations to reach the goal. So here I apply local heuristic, that is why my problem I cannot solve, because it is giving 0 0, means there is no further moves in the solution. Next, second way, now I change my heuristic function as a different way. Now for each block that has a correct support structure plus 1, that has a wrong support structure minus 1. Suppose you see this is the block, here it starts with 0, see bottom of the block we assign 0, and support structure on C is on C is on B, but below B there is no A, so I assign minus 1. D actually based on a C, but in the support structure of below of A there is no A, so I assign it as a minus 2. Here I assign it as a minus 3. And in here this like this, my heuristic function I changed that. You assign plus 1 to every block in the support structure, minus 1 to every block in the wrong support structure. If it is the wrong support structure, we assign minus 1. Right support structure, we assign plus 1. Now again you start here 0, here it is plus 1, it is plus 2, it is plus 3, means I incrementingly assigning, adding simultaneously. So here my problem is my starting state is minus 6 and goal state is plus 6. So my problem I have to reach from, I start from minus 6 and I should reach to the plus 6. Now how we solve this problem? See, first step I start from starting state. Now I made a move that A is placed on the ground. Whenever you place it on the ground, first is 0, so I send 0 0, but a support structure it is not following, it is -1. D is also not following, so its level is 2, so I gave -2. So if you combine the total here, you get -1. Then I placed D on the floor again. Now again it's a heuristic changed to 0, 0, 0, -1. -6 estimation value changed to the -3. -3 changed to the -1. When all placed on the simultaneously on the ground, everybody is 0, 0, 0, it's 0. Now again I rearrange the next. This means from this state I reach to this state, means like a hill climbing. He at every step he is calculating a heuristic. So -6, -3, okay, I'm in a right way. From -3 in a -1, I'm in a right way. Now reached 0. From 0 again when I placed as per my goal arrangement B, now it 1. Again when I placed C, it 2. When I placed means I started from -6 to the 6. Here a slight change in assigning the values of heuristic function take me from starting state to the goal state. So here I reached 6 means I achieved global maximus position. That means I solved my problem successfully. Like this hill climbing algorithms, they see states, possible states, and calculates their objective functions or estimation functions that gives one value at each state, and that help us to take to the next state. So like this hill climb algorithm works. Thank you.